The Arduino Due includes two 12-bit digital to analog converters. With these converters, you can create arbitrary analog waveforms and even stereo music. In this lecture, I will test the Due's digital to analog capabilities using my oscilloscope. I will use a demo sketch that creates a sine waveform and compare the output at two resolutions, 10-bit and 12-bit. Will you be able to notice a difference? Let's see. In this lecture, I'd like to play around with the Arduino Due's true digital to analog converters. And as I said in the introduction, the Arduino Due has got two of them, DAC0 and DAC1. Remember that the Arduino 0 also has a true analog to digital converter. It's got a single one, it's this one here, exposed at A0. The difference between the 0 and the Due is not just the fact that the Due has got two of the digital to analog converters, but also that they are of higher resolution. So in the 0, the DAC is a 10-bit DAC. In the Arduino Due, it's a 12-bit DAC. So you get 4096 levels that your output can take. So I've got both channels of the oscilloscope connected. So the blue channel, channel number 2, is connected to DAC1, and then the yellow channel, which is connected to channel 1 on the oscilloscope, that's connected to DAC0 pin on the Due. The sketch that I'll use to do the demonstration of the waveform generator is very similar to the one that I showed you in the Arduino 0 lecture on the same topic. So I have more details there on specifically how to create and generate the waveforms that I've got in the header file here. So please refer to those if you'd like to know more about that aspect of the sketch. In the Arduino Due example, the difference is that I'll be using a 12-bit resolution, which is the maximum for the DAC on the Arduino Due, as opposed to 10 bits on the Arduino 0. And the writing happens in the same way. I use the analog write function, indicate which of the DACs I'd like to write a value to, DAC0 or DAC1, and I just go ahead and pick a value from the waveform table and send it to the DAC. I will do the upload first at 10 bits just to get a visual idea of what 10 bits DAC look like when I do a sine wave, and then I will change that to 12 bits resolution to see what 12 bits looks like. Alright, let's upload. And this is what 10-bit resolution in a sine wave looks like. I've set my horizontal resolution to 500 microseconds per division, and the vertical resolution for both channels to 50 millivolts per division. And if I zoom in, you'll be able to see the samples, or the levels, I should say better, for the yellow channel, which is channel number 1. So go back so that both channels match. Right, there you go. So 50 millivolts for both channels. What if I go to 12 bits of resolution? Let's upload again at 12 bits. There you go. So the signal looks a lot smoother than at the 10 bits, and I will zoom in. Say 10 millivolts. We'll go to 10 millivolts. You can see that it's a smoother signal as compared to the 10 bits of resolution. So suppose what you could do with a 12-bit digital to analog converter when you've got two such converters available on your Arduino Duo is music. It's a typical application. You can connect your two DACs to an amplifier and through that to a speaker and generate two independent sound waves that you can combine into one stereo signal.